right, welcome to statistics. We are going to talk about chapter 3 here, which is measures of central tendency. I'm going to go off and start sharing my screen so you can see what I'm going to be talking about. Okay, so let's go ahead and get that. Share. And we're going to go ahead and look at this. Great. I think I could write that draw. Perfect. All right, so here we are. We have 3 measures of central tendency. Okay, we have the mean, we have the median, that means the middle, we have the mode. Okay, we'll talk about each one of these. Okay, as far as mean goes, okay, in statistics, we have 2 different kinds of things. We have the sample mean, okay, and we have the population mean. Now, the sample mean, this changes depending on which sample I pick. That will change what kind of mean I get. Okay, so this is called a statistic because it changes. Okay, a population mean is called a parameter because it does not change. Once you have the population mean, that's it. It's there forever. Okay? So we use different symbols to talk to this about. Okay, we have the mean, sample mean, we use X bar. This guy is pronounced X bar. Okay, for the parameter for the population mean, we use mu. Okay, this guy's pronounced mu. Okay, it's a Greek letter. The way I write mine is kind of a combination between an M and a U. I'm sure that there are other people that have gone to school in Greece who have much better handwriting than I do. Okay, but that's what mu is. If you're in biology and you have micrograms or microliters, the little symbol before the microgram, that's the same symbol I'm trying to make here. They have different meanings. In statistics, we call this mu. It is the population mean. And in this book, that's what they're going to use this for. We have a sample mean. They're going to use X bar. That's a statistic. Okay, so that's our mean. How do you figure out the mean? The formula for the mean, the sample mean, and for the population mean, they have the same formula. The formula is this guy here. This is called a sigma. It's a Greek letter S. This is the capital sigma. We'll meet the little one in the next chapter, in the next section. Okay, but this is the capital sigma, which means sum. We're going to add things up. And I'll say I equals from 1 to n. What we're going to do is we're going to say xi, or x, okay, which is going to be x sub 1 plus x sub 2 plus x sub 3 plus ... x sub n. All this means on the bottom here, okay, x sub 1, all it means is the first one, the second one, the third one, ... up until you get all of them. Now we're going to divide the whole thing. How many numbers did you add up? Okay, that's all we're doing with this. Okay, and that's what this formula means. We can get a little fancier, okay, but you're going to pretty much see this as mu, this is the x bar. These are not the same thing, but we have the sum xi, and then we usually go from I equals from 1 to n, okay, divided by n. Okay, well, the first time I drew the n over the whole thing, the second time I drew it over that, it doesn't really matter. Okay, it just means add up all the numbers divided by how many things you added up. Okay, so that's our mean. I'm going to assume that you've probably been taking an average for about as long as you've been alive. Okay, but that's as complicated as it gets. Okay, so the average is just, here we have sample average, and we have population average. So this is sample. Okay, sample average versus population average. Okay, so we have sample average, which is a statistic because it will change depending on the sample I take. Population average, it doesn't matter if I ask you, like, hey, what's the gas mileage of all the cars that happen to be in Pennsylvania right now? That population is not changing. Okay, that gas mileage is going to be forever. Like, as far as I've asked you, that's what's going to be. If I take the sample average, like how many cars pass, specific place of business, what's the gas mileage of all the cars that pass this place of business on Saturday, November 11th. Okay, and then we can take that average. That's going to change if I say what's the average of all the cars that pass the place of business on September 12th. And this is 2022. What if I asked you for 2023, 2024? They are going to be different numbers depending on what I take. So sample average statistics will change depending on the time, day, and whatever sample I happen to take. Population average, once I specify what that population is, it's not changing. Okay, so that is what we mean by a mean. Okay, so this is all under means. Okay, so that's one average. Okay, that's one way of getting that. The next one we talk about mode. So I'm going to do this a little bit out of order. Okay, mode is very easy when you guys will like mode. It is the most frequent or most common observation. Okay, so if you ever see those lists like, hey, what are the top 10 cars stolen in New Mexico? They're going to list you a ranking of the most common things. Okay, in this case, we would have 10 modes. They would list you the top 10 cars stolen. Okay, what is the most popular song played on the radio? So they're going to list the top 5 or top 10, whatever it's going to be. It is the most common song that happens to be played on a particular channel. Okay, we don't have a special symbol for mode. We don't differentiate between sample mode versus population mode. That's just how we do it. The tricky thing about mode is that you can have no mode. Okay, if we happen to have a data set that has every value is different. Okay, like if I have, oh, I'd like the sample and have like the number of pets. Okay, we have 0, 0, 0, 1, 1, 1, 2, 2, 2, and some people, maybe we have people who will goldfish. Okay. In this case, we would say there is no mode. Nothing is popping out to be the most common number that is in this sample. So that would be no mode because everything is equally representative. We don't have anything that pops out as being the most common. Okay, so that's one option. You can have an option that says no mode. We can have one mode. Okay, that's going to look like a, again, I could say number of pets. I could have 0, 0, 0, 0. And we have a bunch of people that have maybe 1, 2, or 3 pets. In this case, we have one mode. It happens to be 0. Okay, 0 is the most common number that is found in the list. There's only one of those numbers. There's only one number that's going to do that. That happens to be 0. So in the previous case, right, there were several numbers that appeared more than once. Okay, so in this case, we have one number that appears more than once. Everything appears one time. That's fine. So we would have one mode. It would be the 0. Okay, if we do something like 1, 1, 1, 1, 2, 2, 2, we'll just do 3 2s, a couple of 3s, a couple of 4s, and 5. Okay, so again, 1 is the number that appears most commonly in this list. Everything else, okay, you could have multiple numbers show up multiple times, but 1 appears the most times. So there is one mode, that number happens to be 1. Okay, we go through just do one more example for this. For one mode, okay, so one mode, you have 2, 2, 3, 3, 4, 4, 4, 5, 16, and 20. Okay, so which number appears most commonly? We have 1, 2, 3, 4s. Okay, we have 116, 120, a couple of 3s, couple of 2s. The mode here, there's one mode, it happens to be 4. Okay, and then in statistics books, especially statistics books like one-on-one stats books, like the one you're using, then once we have no mode, we have one mode, we don't go higher than that. We don't do 2 modes or 3 modes. So we go back to just saying that there is no mode. So you can have no mode, you could have one mode. We don't do 2 modes or 3 modes, but usually we go back and we just go back to saying there's no mode. Okay, so one part of numbers that I want to talk to you guys about a little bit, and saying no mode, the first example I gave you was particularly terrible. because in this case, right, I would say, oh, how about this one here, right? We say there's no mode. Or this one, we say that, for this category here, right, there's no mode. You might be tempted to say, well, what about zero? Okay. No mode, the answer to that is the empty set. Okay. So this is representative of empty set. That's a set with nothing in it. Okay. And for people that are going to go eventually into math, I want you to be careful not to do this. This is the empty set. This is the set containing the empty set. Set that contains the empty set. Okay, so it's not February. So this, you have to use your imaginations a little bit. If it's Valentine's Day coming up and you completely forgot, okay, and you forgot to get your sweetheart a Valentine's Day present, you simply forgot to give them any kind of a present whatsoever. That says something about your relationship, and you got to figure that out on your own. Okay, but you forgot. You didn't get them a present. Now, if I go out of my way, give you a box with nothing in it, now that says something different about your relationship than just forgetting the present for Valentine's Day. Okay. It says something different. It's not the same thing. If I give you an empty box and say, here's an empty box, happy Valentine's Day, you may have it, you'll probably have a different reaction than if I just forgot. So I want you to be careful about saying the set containing the empty set. That is one thing. It contains something. It contains nothing. But the set containing the empty set is a different thing than saying I forgot, I didn't get you anything. Okay. So 0 is a different value than none. Okay, so in math, 0 is different than none. They're not the same thing. Okay, I pick on Bank of America a lot when I do my little lectures here. If you're a teller at Bank of America, this is not directed at you. If you're an executive for Bank of America, do not take this idea. I don't have an account with Bank of America because they charge you a maintenance fee. Someday, some of the executives are going to figure out, oh, this guy doesn't have an account with us. They have an account of 0. You owe us years and years and years of maintenance fees. Here's your bill for several $100,000. No. I don't have an account with you. It's not that I have 0 in my account. I have 0 in my account for a different bank, but not Bank of America. Okay, you can have 0 in your bank account, but that is a different relationship I have with Bank of America than just not having an account with them. Okay, I can have 0 in my account at Wells Fargo. They'll also charge me a fee. But Bank of America, I don't have a relationship with. So that's different than not having an account with them versus having $0 in my account. So when you're going back to bringing this back to modes, you can have no mode. There wasn't any number that was the most common thing. You can have a mode, and then that's it. Okay, the book might say you can have 2 modes. That's fine. Okay, in this case, we would have 2 modes. We would have 2, 3, 4. No, in this case, let's get rid of this. So 2 and 3 would also be if we had 2 modes. Okay, but in your book, generally, if you've got more than 2 modes, they just tell you to report no mode. Okay, so the tricky thing about it is don't report 0 unless that truly is the most frequent observation, right? You could have this case. Lots of people don't have pets. Like, that's cool. You don't have a pet. So in this case, the mode would be 0. Okay. Whereas the first case that I put down, okay, we would have no mode. Okay, so that's the difference. And again, tolerate my tangent off to the set containing the empty set and the empty set. But if you're not going to go off and study more math, you probably don't ever need to know. Okay, so that's mode. Then we talk about median. Okay, now median is the halfway point. Okay, when we get to doing some of the homework, you'll see the issue with some of this. Okay, it's halfway. If your n, the number of observations, okay, n is always equal to number of observations. Okay, this is number of observations. If n is an even number, okay, then what we do is we combine the two middle observations and take the mean. We average the two center observations. Okay, so if I have an example, we're going to talk about 2, 3, 4, 10, 11, 1, 2, 3, 4, 5, and 12. If I wanted to deal with the mode, we would say, okay, well, this is 3 in, this is 3 back. So the average is going to be 4 plus 10 divided by 2. So the two center observations are 4 and 10. Added together, we get 14 divided by 2. That's 7. In that case, the median, the center point here, the middle point, is going to be 7. So 7 doesn't show up in my average. 7 doesn't show up in my list. That's okay. That's how we calculate the median, right? If you have an odd number, so if number of observations is odd, okay, it's not misunderstood. That means that we have 1, 3, 5, or 7. Okay, so if we have 4, 10, 11, 13, 20, 2, 3, 4. Okay, in this case, we go 2 up, then there's a middle point, we go 2 down, there's a middle point, and then 11 here, that would be my mean. The thing that's going to drive you nuts about this is that they must be sorted in order. Okay, we have to put the things in order. Okay, so put observations in order. You have to sort them. Okay, your calculator will do that automatically. But as I was going through the homework, I would rather sometimes not type everything in the calculator. If all they're going to ask me for is a mode or a median, I would rather just do it on paper and pick it out. Okay, taking it into the calculator takes a lot of time. So if n is odd, what we do is we say, oh, it's n plus 1 divided by 2. So in this case, we have 1, 2, 3, 4, 5 things. We have 5 plus 1 divided by 2. Our answer is 3. It is the thing that would be in the third position. 1, 2, 3, the third position. That happens to be 11. Okay, so that's how you figure out the median. Okay, in the example we have up here, okay, if n is even, what we do is we take the n and then divided by 2, and then take n divided by 2 plus 1. Okay, so in this case, 1, 2, 3, 4, 5, 6, and divided by 2 would be the third position. Oh, 4, and then the thing next to it, the thing that goes up 1 point. So 4 and 10, we add those together and average them. That's how we got the 7. 7 is not part of the list of data that I gave you. Okay, we want the third and fourth, the things in the third and fourth position to be our median. Average those, that's how we're going to get our 7. Okay, so when you get this number, this n over 2 number, this n plus 1 over 2 number, that's not your answer. That's the position of the answer. Okay, so be careful about that and make sure that we are getting the value that's the middle number and not the position value of the middle number. Okay, that is a very common, that's a very commonly missed quiz question. Is that people, oh, the median, and they write down 3. Like, that's not the answer. The answer is 11. The answer is found in the third position, but that is not the answer. Okay, so be very careful about that. That is a thing that is very commonly misunderstood, and it's a very common mistake students make. Okay, so we have our mean, sample mean versus population mean. Remember, population mean, it's a parameter. They use Greek letters. Sample, we use Latin letters. Sample mean, this will change depending on the sample. Population mean, can't change the population. It's always going to be the same. The parameter is always going to be. Formula is add up all the numbers and divide. Okay. The mode is the most frequent or the most common observation. Okay. If you have qualitative data, then you just look at the table of things that you have. Like if I ask you, like, what's the most common car stolen in New Mexico? Oh, we would go through and take out all the police reports and find out what is the make of each of the stolen cars. Whichever one tops that list, that's your mode. Okay, that's the one that's the most commonly stolen car. Okay. For median, we're going to do is we're going to count the number of observations. Usually they will tell you in the description of the homework, and then they will let you have at it. Okay, so I'm going to go ahead and stop this video. We'll talk about one more thing, and then we'll do some homework demonstrations. Okay, so we'll say end, and I will see you in the next video.